Hello, in this video we will learn how to get the inverse of a 2x2 matrix. So if this was to be our 2x2 matrix ABCD, how would we get the inverse? So first of all, what you should do is get the reciprocal of the determinant. So 1 over the determinant of A, and then that times the following matrix. So this is going to be a scalar. So we know how to multiply a scalar times a matrix, so that should be pretty easy. And the matrix that we will multiply that by is D, negative B, negative C, A. So in case you ever forget, imagine that you kind of have a mirror right here, and you just flip this two, but then kind of placing the mirror there makes the the place where the mirror is at or whatever negative. I don't know, just find a way to remember it, and so that's the way we find an inverse. But you might see kind of an issue here. So what would happen if the determinant of A is equal to 0? You know that 1 over 0 is undefined. So actually, you cannot get the inverse of a matrix if the determinant is equal to 0. So this is the inverse as long as determinant of A is not equal to 0. So we will work on an example right now. Okay, so they tell you that you need to find the inverse of this matrix. So this is A, and we want to find A to the negative 1. So first of all, we want to find the determinant. So it's going to be 1 over the determinant. And so the determinant, as you may recall, is the difference of the product of the elements of the diagonals. So it's 2 times 5, that's 10, minus 4 times 3, that's 12. And then we will multiply this by the matrix, and remember we have our imaginary mirror right here. So it's going to be 5, negative 4, negative 3, and 2. And so we will multiply this matrix times the scalar right here. This scalar is negative a half if we subtract 10 minus 12. And so negative a half of this matrix is equal to negative 2.5 to 1.5 and negative 1. And so this is equal to the inverse of A. And so you know that A, for example, when you have x, so you know that x times the inverse of x is equal to 1. And that is kind of also true to matrices. So A times the inverse of A is equal not to 1 but to the identity matrix, which you can think of the identity matrix is basically kind of the one of matrices. So there's not just like a number 1, it's the identity matrix, and the identity matrix has various dimensions. It depends on the A, and so we will learn about that in the next video. So never mind, since we have time, let's work it out. So we have these two matrices, we have A and A inverse, and now let's multiply them and find out what's the identity matrix. So Okay, so let's multiply them. We already know how to multiply matrices. Since it's 2 by 2 and 2 by 2, we see that the adjacent numbers are equal, so we can multiply this without issues. And so our first entry right here will be 2 times negative 2.5, that is equal to 5. And then, no, that's negative 5, I'm sorry. And then plus 4 times 1.5, that is equal to 6. And so here our first entry is 1. So we can erase negative 5 plus 6 and replace that with a 1. Next, still first row, second column, 2 times 2 is equal to 4, plus 4 times negative 1, that is equal to negative 4, and so 4 minus 4 is equal to 0, so we will replace that with a 0 right here. Next, second row, for first column right here, 2 times negative 2.5 is equal to, 3 times negative 2.5 is negative 7.5, and then plus 5 times 1.5 is 7.5, and so negative 7.5 plus 7.5 is just equal to 0, so we replace that with a 0. Then our second row and second column, 6 plus 5 times negative 1, negative 5, and 6 minus 5 is equal to 1. And so, oh surprise, we have found out that the identity matrix is a matrix. So it's a square matrix with the main diagonal containing only ones and all other entries being equal to 0. So in this case, we see that our main diagonal, this is the main diagonal, is equal to 1, and all other entries are equal to 0. So for example, and it has to be a square matrix. So a 3 by 3 identity matrix would be a matrix with the main diagonal having 1 and all other entries being equal to 0. And of course you can make this as big as you want, as long as you keep it being a square. So for example, this is a 5 by 5, and we just have our main diagonal being 1s and all other entries being 0s. So this is our 5 by 5 identity matrix.